This is section 3.3. This is part 4. We have been using the slope-intercept formula to find the slope of a line. And what we've been doing is we've rearranged something so that we had y equal to it and we match this pattern. And then the coefficient of your x is your slope. So let's try this with 4y equal to x plus 3. One thing you want to remember is that that is a 1 in front of that x. Now our y term is already by itself. We want the y by itself, and I need to divide by 4. And so you need to remember to divide each of these by a 4 as well. Those should cancel out if we've done it correctly, and you should get y equal to 1 over 4 does not reduce, so I have 1/4 x. And then 3 over 4 also does not reduce. So I have 3/4 here. So what is your slope? It is the coefficient of x. So this slope is 1/4. Okay, we're going to be getting more practice with this in our next type of problem, but we need a couple of definitions first. Okay? Okay. So here are some definitions. These are some properties. Parallel lines, which are lines that never, ever, ever, ever intersect, no matter how far we extend them. Parallel lines have exactly the same slopes, okay? They have to be precisely the same. And if we can show that two lines have the same slope, we can guarantee that they're parallel. Now, one thing you do not want to do is to graph these and try to guess from graphing whether lines are parallel. And the reason for that is that we are human. Now, it might be that we really do have parallel lines. But if one of them is off just the slightest bit, now maybe we do not cross unless we extend these lines out for 1,000,000 miles. But by definition, it does not matter how far out we extend them. If they ever cross, they're not parallel. And we're human, and we just can't see those micro differences that would make it not parallel. To find out if they're parallel, we must compare slopes. Okay. Now, perpendicular lines. I'm going to let you use this symbol from geometry when you want to talk about perpendicular lines. That's just a long word. Perpendicular lines are lines that intersect in right angles. Okay? So they intersect in 90-degree angles. Again, you do not want to graph these and try to get your answer from just looking at a graph. The most you can do from a graph is to say that the lines appear to be perpendicular. And again, that's because we are human. We can't see the difference between a 90-degree angle and an 89.9993-degree angle. One of them would be perpendicular lines and the other one would not be. So again, we have to compare slopes to find that out. Now, what's the property for perpendicular lines and slopes? They have slopes that are reciprocals with opposite signs. So what I mean by that is if one of them had slope 17 over 19, the other one would have the slope 19 over 17. You flip the fraction and they have to have opposite signs. Now, why they have to be reciprocals is harder to understand, but if you think about the opposite sign bit, that's pretty easy to understand. Remember, this line has a slope that's negative, so it's going to look something like that. It's going to be going down from left to right. If you think about trying to draw a perpendicular line, it must go something like this. It must be going up. And if it's going up, it has a positive slope. So this is kind of what's happening with the opposite sign bit. Okay. So how do these problems look? You will be given two equations. You will be asked to determine whether the two lines are parallel, if they are perpendicular, or neither. Neither would be two lines that cross, but not in a right angle. Okay? If we have exactly the same slopes, they're parallel. If our slopes are reciprocals with opposite signs, they are perpendicular. If we get any other combination of slopes, it's neither. Okay, so we are going to continue to use this formula. We're getting more practice with it. We just have to figure out the slope for 2 lines in a problem instead of just 1. Okay, so starting off with this one. We want to get our y by itself so we can use our formula. So I need to take this negative 4x and move it over to this side. So I'm going to add 4x to both sides. This gives me 3y is equal to 4x plus 4. And again, the reason I wrote the 4x first is because it matches the order here and it will be easier overall. Okay. Now I don't want 3y, I want y, so I divide everything by a 3. This gives me y is equal to 4/3 x plus 4/3. So what is the slope of this first line? It is the coefficient of x, which will be 4/3. Okay, so now trying this one. We want our y term by itself. So I'm going to take this 8x, negative 8x, and move it over to the right-hand side. So I'm going to add 8x to both sides. Okay, so 6y is equal to 8x. Now, you can keep the plus 0 around if you want to. And there's a reason you might want to. It's not so critical in this section, but it is in the next. So I'm going to kind of mention it now. It may not make complete sense to you just yet. Don't worry about that. It's just an introduction. It's just an exposure. Okay? Now I want the y by itself. So I need to get rid of that 6. So I'm going to divide everything by a 6. Okay? So this gives me y is equal to 8/6. That reduces. If I divide each of these by a 2, I get 4/3. So this is 4/3 x, and 0 divided by 6 is a plus 0. Now, the reason you might want to keep a 0 around is so, sorry, that was the wrong note card. That is so that you have this plus b part of it. And I mentioned earlier, we don't really deal with that part in this section, but it keeps the b around. Numerically, if you're just rearranging things, you can drop that plus 0. It's understood to be there, okay? So what is the slope of this line? It's going to be 4/3. Okay, so we've calculated both slopes. Now we look at them and try to figure out what it is we have. These two slopes are the same. So these two lines are parallel. Okay. The reason I let you use the symbol for perpendicular but not the symbol for parallel, because in geometry, the symbol for parallel is 2 straight lines and it looks a whole lot like an 11. And since you don't deal with numbers too much in geometry, it's not so confusing, but here it would be.